Hi, everyone. I was going to say good morning because this is a West Coast NLP conference, but I started looking at the chat and see people from all around the world. We have people from Brazil, Switzerland, UK, Romania, Italy, Iran, and India. So hello, everyone, and welcome to the West Coast NLP 2020. This is going to be our first invited talk session. I am Alborz Geramifard. I'm a senior research manager at Facebook AI, working on conversational AI, and I'll be chairing this session today. This session is called Scalable and Multimodal NLP. This is one of the two sessions on this topic. We will have three speakers, 25 minutes each with 5 minutes follow-up Q&A. The first invited speaker that we have today is Hwang. It's going to be a recorded talk, but we would follow up by Q&A. Mayu is also going to join us on this stage. It's my privilege to introduce Mayu. She received her PhD in computer science from CMU in 1993 as and she was one of the main contributors of the Sphinx 2, a continuous speech recognition system. She also worked at Microsoft in United States and China for 18 years and University of Washington for 4 years, publishing several papers and delivery industry products. She's currently an IEEE fellow who is passionate about bridging the gap between academia and research and industry. And following this passion, she has spent 4 years at a startup company whose main focus are personal assistant in automobiles and smartwatches. She's now focusing on personal assistants for productivity after returning to Microsoft a few months ago. So let's join and listen to her talk named NLP Intelligence for Microsoft Outlook and Teams.
Thank you for having me. My name is Hwang. I work for Microsoft Search and Assistant Intelligence team. I would like to talk about some work we are doing at Microsoft for improving intelligence across Microsoft Office products. This is a collective work across many teams. I'm privileged to summarize them here. There are a lot of work around Office intelligence at Microsoft. I will be talking about only a few areas that I'm familiar with. I will be using Outlook and Teams exclusively for demo, though please understand this covers only a very small corner of Microsoft's AI efforts for Office. Office is all about helping our users to achieve more with less. So task completion is the main goal. I will first showcase the features implemented by the conventional Cortana domain intent slot tagging approach. Then move on to how we expand these features to all other Office international markets. Next, I will talk about the data flow graph approach proposed by semantic machines to model from input query directly to an action graph. Finally, I will touch bases on Smart Reply and Smart Compose and summarize today's talk. Here is a diagram to show Cortana workflow. Automatic speech recognition, or ASR, is applied to convert speech into text. Natural language understanding, or NLU component, extracts the domain, intent, and slot information in the text. State tracker keeps track of dialogue state in order to generate an appropriate policy action. For example, a query like, "What's the weather in Boston today?" will trigger an API call to weather.com. Natural language generation, or NLG module, then generates a response text based on the result of the action. The response text is then sent to text-to-speech, or TTS, to synthesize the speech output. In this diagram, speech input and output are optional. There are more scenarios that are just text input directly with text output. A big advantage of such an approach is modularization. It is easy to add a new domain or skill, and different domains can be trained mostly independently. We design a comprehensive set of domain, intent, and slot schema for Office in order to support natural language-based search experience and task completion. One of the key work items here is personalization and contextualization. Contextualization is important, especially for co-reference resolution, such as finding what there means in what is the weather there. On the other hand, the most useful personalization we find is the user contact list. In Outlook and Teams, different users each have their own contact list. No speech recognizer can cover every single possible name. ASR has to either use subword tokens as their vocabulary, as in many end-to-end systems, such as RNNT or transformer-based systems. Alternatively, we use a class-based N-gram language model, where content names collectively form a class. Names from a content list and their variations, such as nicknames, are represented with a finite state transducer. The user-dependent name FST replaces the name class in the class N-gram LM at runtime dynamically. For personalized NLU, we extract N-grams from calendar meeting titles as additional features in order to identify meeting title slots. Now let's watch a few demos. In the first video, you will see Teams on mobile in action. Watch out the Kingston device at the end of the video. Kingston is a small device for Teams with a screen. In the demo, you will see looking up calendar, joining a meeting, calling and messaging someone, and sharing a file are all seamlessly easy. Let's watch the video.
What do I have this morning?
I'm finding 3 events this morning.
Call Megan.
Calling Megan Bowen. Hey David, what's up?
Hey, I just want to chat with you about the quarterly review.
Can you send over the latest presentation?
Share the quarterly review deck with Megan?
Should I share this?
Yes.
I'll send that.
Send a message to my next meeting. Looking forward to sharing Q2 results.
I'll send that.
Cortana, join my next meeting.
Joining your 2:30 p.m.
Cortana, present the quarterly review deck.
All right, I'll bring up the presentation.
Cortana, go to the proposal slide. Okay, everybody, let's get started.
The second video is Cortana on Windows desktop. There are many cool videos here. We will show the first segment only, but I encourage you to watch more segments after that to discover all the cool features provided for your daily work and life.
Cortana, am I free at 9?
I see one event for today around 9 a.m.
All right, everyone, let me introduce you to Nestor. He's gonna...
What's next?
The last video is email search using natural sentences. For this one, I'm going to fast forward to where we want to listen to.
I'll start here by looking at some of the latest search features I'd mentioned earlier. One is that natural language search, where I can search unread from Deborah and get all of those results quickly in my item list. Another one was Alex with attachment. All of those results with attachments from Alex super quickly in the item list. I also talked about speller. Ever misspell something, especially during a demo? Now I get results based on the misspelling right there in the item list super quick, with top results separated by a section of all results below. Now, what about those admin preferences that we were managing for Outlook that I showed you earlier? Let's go into our mail reading preferences and take a
Sorry, that was too much. So now next now that we have built the system in English and demonstrate its value, we are expanding these features into all other languages shipped by Office. To expand to the international markets quickly, we utilize the transformer-based language agnostic representation to encode the input sentence. In this case, we are using our Turing Universal Language Representation, or TULR. On top of the encoder is the domain, intent, and slot layers. For fine-tuning, the English NLU training data are machine translated into all other languages with slot tags preserved. To improve MT, we sometimes have to adapt the MT system with domain-specific training data. The translated data are then used to fine-tune both the encoder and the domain intent layers. Finally, to save computational cost and to reduce latency, a student model is trained based on the teacher's distillation. Sometimes parameter quantization is also necessary. We will be shipping this to non-English markets, hopefully by the end of the year. Here is the illustration of the transformer-based model mentioned above. The encoder is shared across all domains and all languages, while the top domain intent slot layers are domain dependent and yet still language independent. And across all different domains, they share the same representation. Therefore, the representation is computed only once for all the domains. And no language identification needs to be done to understand the semantics of the input query. The Cortana domain intent slot approach works well for most of our Office scenarios. However, there are some scenarios where human-machine interaction involves many turns of conversation. Hence, a more powerful assistant is needed. For example, the calendar app. Let's watch a video to showcase our vision using semantic machines, where we want to be able to jump around multiple domains and intents seamlessly and support multiple queries, multiple intents in one single query.
What do I have today?
Here's what your day looks like.
Today you have take a walk outside at 8 a.m., your one-on-one with Anjali at 10 a.m., lunch with Tom at noon, and your app kickoff at 3 p.m.
Go ahead and reschedule my walk to tomorrow at the same time.
Sure. I can move take a walk outside to tomorrow at 8 a.m. Is that right?
Yeah, that sounds great.
Okay, I've moved it to tomorrow.
And schedule a cram session with Nicholas and his manager from 9 to 1:30 today. And we're going to need a room in Bellevue.
Oh, okay. I'll invite Nicholas Cohn and Michelle Estes to the cram session, and I'll put your meeting in City Center 2605. Does that look good to you?
Yeah. And push back my one-on-one with Anjali to tomorrow.
All right, I've booked your meeting. And here are a couple of options to meet with Anjali Bhatt tomorrow.
Is there anything later in the day?
Let's see. How about this one?
Yeah, that'll work. And is she invited to the app kickoff this afternoon?
No, she's not on the invite.
No, please send it to her.
Okay, I've forwarded the app kickoff to Anjali Bhatt.
Great. Oh, right. After my last meeting today, schedule 30 minutes to pick up the birthday cake.
Sure. Pick up the birthday cake at 4 p.m. Is that right?
Yep. And remind me, where is my lunch meeting today?
Lunch with Tom is at Liberty Cafe.
What's the weather going to be like?
It'll be mostly sunny and 71 degrees at Liberty Cafe at noon today.
Can we eat outside there?
Yes. Liberty Cafe has outdoor seating.
And can you send directions to my car?
Connecting to car skill. Sure, directions to Liberty Cafe have been sent to your car.
When's our next review with Cyrus?
Your next quarterly review with Cyrus Nafani is Tuesday, June 11th at 10 a.m.
Schedule a 2-hour dry run with Benjamin McIntosh the Friday before that.
All right. Does this work for you?
Yep, that looks great.
I've scheduled your dry run with Benjamin.
Thank you.
Happy to help.
Here's what training data looks like for semantic machines. It consists of query and action graph pairs. Given the query, when is the next retreat? The dialogue planning model will output an action graph. The action graph can be described as a sequence of function applications. In this case, the user intent is to query the start time of an event. So start is the root node, with find event as its argument. Find event has an event spec parameter, which is specified by name and start, requested by the user. Training data is collected and annotated as such. Then a pointer generator network is trained as the dialogue planning model. Developers have to implement each function, and the returned value of each node is then attached to the node. Machines execute the functions to extend or modify the data flow graph. In the pointer generator network, the source text input consists of queries X and outputs of the planning model Z from the previous C turns. So here you got Z minus 1, X minus 1, all the way back to Z minus I minus C and Xi minus C, plus the current query X of I. The output of Z of I is the action plan for X of I. Z of I consists of a sequence of functions with parameters. For more details, please refer to the reference at the end of the slide deck. Now let's move on to Smart Reply. Smart Reply refers to the chat scenario. When one party says something, the machine suggests some compact replies to allow the second party to click on one of the suggestions as reply. in order to save keystrokes. For example, the reply to "Want to meet up for lunch?" can be "Sure," "Sorry, I can't," or "What time?" We want the suggested reply to be both relevant and diverse. For example, you don't want "sure," "yes," "okay," all be the only 3 suggestions, as they all mean the same thing. This figure shows our design. First, we collect message and response pairs as training data. Then we train separated message encoding and response encoding and minimize the distance between their representations. The distance can be their cosine similarity or inner product. At runtime, it's important to achieve low latency and avoid generating offensive responses. So we use an information retrieval approach to suggest the base 3 responses as follows. After the representation model is trained, we select about 2,000 to 3,000 fixed responses. Pre-compute their representations in blue with the trained response model. We also trained an RNN-LM and compute the LM likelihood for each response in orange. These 2,000 to 3,000 responses are also pre-clustered in green, such that each cluster means the same response. For example, "Yes," "sure," "okay" are likely to be in the same cluster. Again, these blue, orange, and green arrays are pre-computed after the encoding model is trained. At runtime, when a query comes in, that is, when the first party says something, its message representation is computed. The distance of the query representation and each of the response representation is smoothed with the RNN-LM likelihood score. Then the top K responses are selected. Finally, using the cluster labels, we dedupe the K responses and output the best 3 clusters. Smart Compose is to help users finish their sentences in the middle of composition. We use either LSTM or transformer to predict the next few words until end of sentence symbol. Here is a quick demo. One challenge we are facing is to deal with eyes-off data. Microsoft reflects strictly user privacy. Hence, compliance means all user data are eyes-off. Smart Compose and Smart Reply also have to avoid generating offensive words and also prevent hackers in reverse engineering to guess what kind of user data the model has been fine-tuned on. In summary, there are a lot of NLP work within Office Suite. We can categorize all the features into search versus assistant, 2 categories. Search is powerful and enables users to find what they need quickly. Email search, file search, people search are the 3 most demanded areas. Personalization and contextualization are used to improve system performance. Microsoft is used to offer answers from Microsoft Graph is used to offer answers from a different technology. All the answers need to be re-ranked in the end to offer the final best answers. This is a company-wide collaboration. Thank you for listening and look forward to your feedback to Microsoft Office. It will help us achieve our vision and advanced artificial intelligence.
Great. That was great, Mei Yu. I would like to ask Mei Yu and also her colleague Ming to join us for the question and answering section. If you have any questions, please feel free to put the question in the chat menu on the stage. I will be more than happy to relay those questions to the folks over here. There we go. Hello, Ming. Hello, Mei Yu. Thank you for joining us. So I'm looking through the questions over here. The first question comes from Yingding Hwang. He's asking, does the presented smart reply also works on other language data than English, for example, German?
We are working on that. Right now, we shipped English only at this moment. But yeah, that's definitely in the charter.
Great. So feel free to put the questions over there. I had one question myself. So the demo that you have with respect to the calendar is very cool. Like the vision for Microsoft, it has includes many terms. I've also worked in the Canva AI. So I'm curious, where you are with respect to this vision. Is it currently we are how close we are to actually have something like this that we can use day-to-day basis?
Just for calendar itself, it's pretty mature. It doesn't have everything in the vision, but there's a lot of things to be done or can be done already. And we are at the final stage on how we can integrate this into Outlook so that user doesn't feel like I'm running a separate app. So it's more a UX design right now before it gets shipped.
Got it. Awesome. Looking quickly back on the stage, let's see if there are other questions being posted. Someone is asking about link to the references. I would believe we can share maybe the slides as well for the people who are interested and wanted afterwards to make them available. Another question comes from George Foreman asking, in the demo, the user responded, yes, that's great. Since yes is sufficient for the computer, is the that's great feeding a rating feedback system?
You mean feedback for the next turn?
If I interpret correctly, George, feel free to chime in. So when someone says yes, that's great, so yes becomes essentially confirmation. But with that's great part being used as a feedback to the system, that was a positive thing, or as a positive reinforcement or something like that to the system?
Right now, the training is based on response, message and response pairs only. We don't have continued feedback.
Got it.
Not right now.
Just on top of that, right now, so I think you refer to kind of active learning, online learning type of thing. Right now, it's not directly used. Yes, that's great. It would be considered as all yes. So it's the same, but it is our plan, leveraging user feedback in many different formats would be definitely in our near future plan for leveraging that.
Got it. Thank you. Next question from Xintong Li. How many chat turns do you think it can handle?
What do you mean? How many chats?
I think they're asking do you have any limits on the number of turns that the context and the conversation can be carried over?
Currently, I don't think so, Ming.
I don't think so. So if you consider the conversational kind of scenario, you can pretty much consider every turn as a multi-turn, right? So the best modeling approach is you do not separate single turn and multi-turn. It's a matter of how much context you get. So theoretically, there's no limitation on how many turns you can do. However, in reality, just think about the amount of context you have to pass to the current turn. So if you let it to be infinite, first off, it will be noise. Second, it will be capacity to the system. So in reality, there is a cutoff on how many turns you could save for the context. But theoretically, there's no practical limitation on that.
Thank you. Thank you both, Mei Yu and Mingwu. I see there are more questions. It would be great if you guys can actually go to the stage and respond in the chat. But given the time that we have left, I would like to go to the next speaker.